Welcome back, everybody. Please turn your monitors sideways so that we can connect as humans and not have these screens in between us. We are in week 5. And first thing I want to point out is I've had some people who are like, help, help, I've fallen off a boat. I'm in the middle of the ocean. I could swim, but it's a big ocean. Help. I've had some people who needed help, whether with programming or my IT lab or whatever. So there's now a link here within Blackboard. There are tutors available to help you for free. Click on that link. It's going to take you to a photo that I took. And with my phone, I have synchronized my phone with Google Photos. Google Photos now allows you to store an unlimited number of photos for free for the rest of your life. You can easily share the photos. So if you don't, I don't know how to rotate them though. If you don't have Google Photos yet, it's cool. And you delete it from your computer, it deletes it on your phone. It's awesome. Anyhow, here are the hours and the rooms for the different tutors for CIT-15. So if you're needing some help, here are people who can help you out. Go check them out. And if one can't answer your question, go visit the other one. Because I heard one of those people wasn't helping so much with the HTML. They were like, they didn't cover that when I took the class. So check out the tutors. That's the first thing you need to know. Since we are in week 5, in Blackboard, you need to go into assignments. And you should be through all of week 1, all of week 2, all of week 3, all of week 4. This one, your grade, awesome. And then you should be into week 5, which there's just the programming and a video. So you're going to make a video, and that's pretty easy these days. Not so easy in the past, but you can use whatever software you want. I show you how to use Windows Movie Maker, but however you want to make a video is fine. Anyhow, that's your Blackboard assignments. And then in my IT lab, we are in week 5, so we're finishing up the last week of Microsoft Word. So you should do this one right here. Should be through all these, including the one that came before this in Windows. So you should get the last Word assessment. And then under exams, Office lab test. Since we're finishing up Word, go ahead and do the Word lab test. I don't really like this test. I don't like the way it's written, but this is standardization, right? Here's a common assessment that's been written by a committee of people. Anytime you want things to be done just in a very average fashion, get a committee together, right? Because it's just going to even everything out, right? Instead of doing it one way or the other way, it just meets in the middle and you just get this blah. So it's not very cool, but you got to do it. And it's called test, but don't freak out. You can take it as many times as you want, I think. I don't know. If you can't, just let me know. But, you just do it, and then you upload the document, and it grades it. And it's real rudimentary, step-by-step. Do this, do that, do that. So you should finish that, and then you should also do the quizzes, Chapter 5 quiz right there. So that's where you earn your money this week. Once you've earned your money, you might drop in and check out the lectures in here, see if there's any other little Easter eggs, little hidden jewels, right? That, hey, there's something down here at the bottom Todd didn't cover in class. Like, he didn't talk about 3D printed guns. And actually, you know what? The lectures I'm giving in class are going to not totally correspond to the line up here. So even though this lecture you're watching, which is the week 5 lecture, right, is going to be found under week 5 here when it's up, all this stuff we talked about last week, I/O devices, keyboards, pointing devices. And we never got to 3D printers and printing human organs and the Bay Bridge lights and 3D printed guns. We never got to that. And that's some pretty awesome stuff. So, if you're curious, you can check that out. Likewise, the week 4 lecture, what was that? I think that was, here we talk about storage. I don't know. So I'm just trying to adhere to the textbook we have now, which is a little bit different than the way those lectures are organized. But don't sweat it. You're learning the material. So that's what you need to do. The lectures, of course, you don't need to do them. That's not where you earn your money. But you need to do the assignments and then all that My IT Lab stuff. So somebody asked me, where do we do this coding stuff, right? That was your question? Yeah. So the coding stuff, you can watch this video, and it should show you how to do it right there. And you click this link, and it should take you to it. And so here's Code Academy. And who knows where it will take you when you first get there. It takes me to the command line because that's the last one I looked at. But you want to come to HTML and CSS down here at the bottom, and then you need to be working through that. right? And then sending me screenshots showing you've done stuff. You can see I've been through all of it. Took so much time. And so that's where you do your coding stuff, and get help with the tutors on that. Maybe just stop in and see the tutors and say, hey, I'm starting from ground zero with this. Will you work through it with me? And they should be able to figure out, even if they've never done it before, because they've had some experience. What was your other question? You had two. I think it was MyIT Lab, the MyIT Lab, when I answered that. Anybody else have any other questions, comments, concerns?
What if you're stuck on something on Code Academy and you're not quite getting it?
Yeah, so that's a really great question. What if you're stuck on Code Academy and it's not working and you're like, hey, so this is what I recommend. First, try to solve it on your own. So let's just say I'm in here and I'm doing, like whatever, unordered lists, and it's not working for me for some reason, right? Like I submit and it's like, nope, sorry. Okay, so first thing you could try is reset code right here, reset code, and that's going to reset it. So I could start over. Maybe I screwed it all up. Let me just reset it and try again. So if sometimes maybe you accidentally hit something right there and you don't know it, right? Now that's not going to work, right? Just because I've made one character in there, it's going to be like, that doesn't make sense to me, wrong answer. So if you hit reset code, you get to start over, and no penalty for that. You're just starting over on this one assignment. And then make sure you really clearly read this description of what you're going to do. Often there's an example. So I could just copy that example, right? And then I could come over here and inside my body tag, in your body tag, create an H1 tag and put text, some random thoughts. Under the H1 tag, create a paragraph using P, and finally create an unordered list with ... So my first thing is I go between my body tags. And HTML, one person was a little confused by this. You have to have an opening and a closing tag, and they have to cascade in and cascade back out. And what that means is, like, if I have a H1 tag, if I have a body tag, I'm going to do H1. I'm going to open up my H1. And that's like saying I'm going to put a heading stuff here, so I could put, and it wants me to do some random thoughts, right? And then, I would not want to do this, right? Because now my tags have not opened and closed in some sort of logical order. If I open something, I need to close it, right? And I could put stuff in it, right? So here I've got the body tag. It's been opened, right? And I put the H1 tag in it. And so here that H1 tag is inside the body tag, right? And but I've opened it and then I closed it. And if I want to put something more in here, like I could put an emphasis tag right there. Whoops, that's not what it looks like. Nor is that. But that is what it looks like. I need to close that. And notice I'm opened the emphasis tag and I closed it. And that's inside of H1. I would not put my emphasis tag, here. Right? Because that's not the sequential in and out, open, close. You can put things inside the way that HTML works. Does that make sense? There's this nesting thing of tags. So one person's confused. And you could use this indentation to get the nesting looking a little bit more logical. What's up?
At the bottom of the instructions, it says stuck.
Yeah.
If you click on that, it'll actually, most of the time, just show you how to do it.
Yeah, and a lot of times down here you got stuck, get a hint, and it really gives you a real sort of, yeah. So there's the first one, put in the H1 tag. And then my next one is it wants me to do create a paragraph using the P tag, describes a list you'll make. So I do my P, and here is a list of something. And then I close my P. And then it wants me to put in an unordered list. So I could just copy this right here, Control C. And if you drop in a copy, you don't make any mistakes. And then just I'm doing some indentation to keep it a little bit easier to read. And I do that with the Tab key. I could hold Shift Tab to bring that back out, right? And then it wants a tag which contains a list of 4 random thoughts, each of which should be placed inside of an LI tag. So I need 4. So let me just copy that, and then this is going to be 3 and 4. So that's those are my suggestions for if you get stuck. Is try reset, make sure you read through real clearly this instructions, or what you're learning, and then follow the instructions and check the, the hint deal here, stuck, get a hint. And if that doesn't work, you could go to like, search MDN, which is sort of the definitive source for looking up HTML and CSS help. MDN stands for Mozilla Developers Network. And you could search MDN, and what I'm learning about there is unordered lists. So I could put in UL, right? And it tells me that, hey, you're learning, unordered lists. So I could just bring that over and say MDM, unordered lists, and I could look this up, and here it is, MDN, Mozilla Developer Network, Mozilla as in Firefox browser. This is the best. And then they have an examples over here, and I could, I'm looking at unordered list tag UL, and I could look at examples, and I could see some examples. I could even just copy that example and put it in and add one more item, and it'd work, right? So those are all the suggestions for getting HTML stuff going well. If you wanted to, you could get editor, some sort of an editor. So I use WebStorm, and then that will help you. I'll just show you WebStorm. I think I also have Atom. So Atom, you could get Atom. You could download this. This is free, and I could do File, New File. And I could save it, and I'm just going to call it sample HTML. And then I could go get my code. I haven't used Atom, so I'm not totally sure. I could get my code here, and I could bring it into Atom. And I could paste it in. And then, I think there's some way to format it, but I don't know Atom. So I'm just looking here. Edit, selection. Anyhow, in WebStorm, so you'd have to, let me just open up samples. So if I create a new file in WebStorm, new HTML file, temp, and I paste all my code in here, right? I could come up here. I could go to code, reformat code, and it reformats it for me. Plus, it'll show me if there's an error, right? So if I left that out, put a little red line there, and it says, hey, there's an error here. So it helps show me the errors. So WebStorm's a really great tool to use, and if you're thinking, hey, I like this coding thing, you could download and install WebStorm. I recommend WebStorm. And I could get you a license for that. Just send me an email and I'll put it up for you. But there's a great training where you can learn a little bit more about using WebStorm here on Pluralsight. So you could sign up for that if you really wanted to get into it. And I'll show you how to do HTML and CSS in WebStorm and how to get it going, how to use it as a piece of software. So if the coding deal is really interesting to you, just start using WebStorm. And come take a look at this training. And you could copy your code from Code Academy into WebStorm, make sure WebStorm will check, make sure everything's formatted correctly and there aren't any errors, and they'll tell you if there are errors, and then you can fix them if there are, and you can copy it back out of WebStorm and put it into Code Academy. So if you are interested in that, right here, I'll just show you. I think you'd actually have to have me email it to you. But here's the license. So you could just copy that and paste it in. I'll have to email it to you. That's a lot to type. Just let me know if you want it. So good question. Coding. What else? Any other ones? All right. So we're going to do an exercise. I need you all to get out a pen and piece of paper. And the exercise is going to be to do the decimal numbering system, and then the binary numbering system, and then the hexadecimal numbering system. So base 10, base 2, and base 16. And we'll look at that answer as soon as you guys have done it. So you should have done something like this to create the decimal numbering system. The first thing you should think is this is base 10, decimal. The prefix deci means 10. And base 10, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. That's the first thing you should think when you're creating a numbering system. What's my base? And once you got your base to the 0, base to the 1, base to the 2. And then we know this is a 1 spot, because anything to the power of 0 is what? 1. This is a 1 spot. And this is a tens, because 10 to the power of 1 is 10. 10 to the power of 2 is 10 times 10, 100. 10 to the power of 3 is 10 times 10 times 10, thousands. 10 to the power of 4 is 10 times 10 times 10 times 10, 10 thousands. All right, so now we got our places, and now we could just start putting numbers in there. Since this is base 10, we've got 10 digits to work with. What are those 10 digits? 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our 10 digits, right? And so that's how we could put, any 0 through 9 right here. And when we run out, if we want to go, up to 10, well, we no longer are here if we have 10. We got one of these, right? We're no longer with 10 ones. We got just one 10, right? We don't really deal with, like, having 14 single dollar bills in this example. All right, so that's decimal. I want you now to recreate the binary numbering system. Binary is base what? 2. And the first thing you're going to do is what? 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Okay, so go do it. So what you should have come up with for binary is fairly similar. Well, except don't. Pencils down, pencils down. So whoever was chatting, we're going to look up here now. So same thing, binary. First thing you got to ask yourself is, what's my base? My base is 2. All right, what's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. And then I just figure those out. I got my 1's place, my 2's place, my 4's place, because 2 times 2 is 4. I got my 8's place, because 2 to the power of 3 is 2 times 2 times 2, which is 8. So there's my 8's place. I have my 16's place, yada, yada, yada. I got to figure out the number 42. Well, I'm going to need 132. I'm going to need 1, 8. Now I'm already at 40, and I'm going to need 1, 2. There's 42, and I don't need those guys. I'll put zeros there. So 1, 0, 1, 0, 1, 0 is how you would write the number 42 in binary. So next thing I want you to figure out is base 16, also known as hexadecimal. But here, before you start, 16, right? How are we going to do 16? Because if we're trying to write, representation, like here we have our 1's place. If we want to represent 7 1s, I put in the number 7, and I could represent that with a single character, one character, right? Well, if I'm doing base 16, what happens when I get up to 10? I'm no longer using one character. Or 11, right? Because base 16, I should be able to use all the way up through 15, 0 through 15. But I don't want to have it be represented by 2 digits. So what they do with hexadecimal base 16 is you will use, for your little numbers there, you will use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay? So you'll use, as your placeholders, well, I just showed you the answer. You'll use those as your placeholders. Let me make that bigger. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? This is 10, this is 11, this is 12, this is 13, this is 14, this is 15. And now we're representing, right? We're just representing it, don't trip out. We're just, doing a simple a connection. There's like a lot of aliasing. Alias, right? Like if I was to tell you that, my real name is James Bond and my alias is just Todd McLeod. My cover is community college instructor because I'm deep undercover, right? My alias would be Todd McLeod. My real identity is James Bond, right? It's just, we're using the alias F for 15. It's another way of saying 15. And that's a lot of programming right there, is just understanding, oh, this variable means this, and connecting and filling in a placeholder. So that's what we use for the different placeholders. Do base 16 for hexadecimal. So the first thing you're thinking is 16 to the 0, 16 to the 1, 16 to the 2. And then you might need to use your phone or calculator to figure out what 16 to the power of 2 is, what's 16 to the power of 3, to figure out, what's the 1's place, 16's place, and then after that, go! So what you should have done is you should have said 16 to the 0, 16 to the 1, 62, blah, blah, blah. And 16 to the 0, anything to the power of 0 is 1, so there's your 1's place. If I wanted to write down the number 9, it would just be 9. If I wanted the number 10, it would be A. If I wanted 11, B. If I wanted 15, it would be A, B, C, D, E, F. Right, the last one right there would be 15. And here's the 16's place, here's the 256 place, the 4096's place, the 65,536's place. And by the way, these numbers, because base 2 computers, binary, on, off. And these numbers right here are very computer-esque because 16 is also kind of whatever factor of 2 or something like that, right? I don't know what the right way is to say that, but it's built with kind of this idea of 2s also. So if I want to do 42, I'll need two 16s, which would give me 32, and then I need one 10, which is A, and that's 42. In hexadecimal. And hexadecimal, by the way, hex, decimal is des is 10, and hex is 6. So it's the 10 and 6 numbering system. 16, base 16, it's hexadecimal. Right? How sweet is that? So I wrote a little program where you guys were doing that. And here's a little program that will loop from 0 to 100. And using printing verbs, so print with formatting. And I'm going to format the letter I, and this one here knows to be put in there. So I'm going to format, every time I go through this loop, I will be 0 the first time, 1 the next time, 2 the next time, 3 the next time. And then finally I is equal to 100. Is 100 less than 100? This will be false, so the loop will stop. And then, that'll be the end of the program. But each time through, it'll take the number, whatever number I is, and it'll format it as decimal. It'll print it as decimal. It'll print it as binary. And then it'll print it as hexadecimal. And those are just the secret codes for format verb printing. And you look those up, whatever programming language you're working in. You say, what are the formatting verbs? And so I just looked up the formatting verbs. And I was like, okay, B, that's for base 2. This is for base 16. Right? And here, %D is for base 10. I could look at base 8 if I wanted. That'd be interesting. Right, and so when I run this program, prints them all out. Here it is 0 in decimal, binary, and hex. 1 in decimal, binary, and hex. 2 in decimal, binary. That's 2 in binary and in hex. Right? Here is 12 in decimal, in binary, in hex. Here is 42 in decimal, in binary, and in hex. And a lot of times when you see hexadecimal, it'll look more like this. So I'm just going to come in here and change this. That's just the code. I know that code, I looked it up on that same page. We'll add in this character here. And so you'll have a 0x in front of hexadecimal. I don't know why I'm so zoomed in on that, sorry. Right, but that stuff looks pretty wacky. 0x2c, like what the heck is 0x2c? Well, the 0x just means this is hexadecimal, and then the 2c is your hexadecimal. So you tell me, what is 2c in hexadecimal? You have two what's there. Here's the ones place, right? And then here, what's the next place? 16 to the 0 is the ones place. 16 to the 1 is the next place, so this is 16. So we got two 16s.
30.
That's 32. And we got C, which is going to be 0 through 9, 10, A, B, C, 10, 11, 12. So 12 plus 32, that's 44. Let's check it. 44. Right? So you guys tell me now, let's try this again. What is 3D in hexadecimal? What's 3D in hexadecimal? Figure it out. 3D in hexadecimal. Figure it out. $3D in hexadecimal. So we got 3 16s. What's 3 times 16? It's 30 and 18, 48. Right? So we got 48. And D, we know that this is 10, so we have 48 right here plus 10. This is 58, 59, 60, 61, 61. Now, why use hexadecimal? Because that's a lot easier to write than decimal or than binary. Not much difference, just 2 digits when you look at writing it in decimal versus hexadecimal. But when you get further down and make larger numbers, so let's do that. Let's make a larger number, and we'll run this to 1,000. No, let's do 10,000. No, let's do 1,000,000. Right? So 1, 2, 3, 100,000. We'll do 100,000. Let's run this to 100,000. Wow! Computers are fast. But if you look at 100,000, well, we just did to 99,999. This took 5 digits. That took 5 digits, so that's pretty similar, but this took a whole lot.
Whoa.
Right? A lot of digits to represent that. What about if we do even bigger numbers? So let's do, we'll start out at 1,000,000. 1, 2, 3, 1, 2, 3. We'll start out 10 million. And we'll go 10 million and 100. So here we could start to see, oh yeah, hexadecimal is a little shorter. I could represent that number, whatever it is, right there in 1, 2, 3, 4, 5, 6 characters, versus over here, it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so as you get larger and larger numbers, which you do with computers, because we're talking terabytes, right? And terabytes is like a whole lot of stuff. I can't think of it off the top of my head. But then you're having, what's the memory address of something? What is the memory address of something? Right? And then we're able to see the memory addresses. We talked about computers having memory, and memory is like a little cubby hole where you stick stuff. Check this out. Let's bring this back from 0 to 5. And I'm just going to print out the... I kind of like this example right there. I don't want to get rid of it, so I'm going to do this. Just make a new example. Memory addresses. 8. That's just for fun. And the memory address, so we'll just do a print line. And what I want to print is just the address, the memory address. So the actual location in memory where this variable is stored. Let's see what happens. And I called that one 08. So there's the memory address. Same location every time, right? But that's the address where that variable I was stored in RAM. There's an actual location in RAM, and it's got this number on it, and that's it. And so how would we figure out that number in decimal? I don't know. Maybe we could do this. We could just take that, and I guess we're going to need, I'll just do a print so we don't have a new line, and then I'll add a little dash, and then I'll do a format, I think I copied that, format print line, printf, and I will do this as decimal. Let's see if that works. I don't know if it will. And we just need this to go less than or equal to 1. Let's see what that does. So that's that number in decimal, right? 100. So it's 34,898,576,128. That's the box, the cubby hole, where I have stored 8 bytes of data. I think it's 8 bytes. Let's figure it out. Let's see how many bytes of data got stored there. So, and I'll do a tab there, and then the type right here, and a new line there. So it's a pointer to an int. So most likely that's 64 bits. Most likely that's 8 bytes. 8 bytes.
How do you calculate that? How do you know that?
Oh, actually maybe it's not because it's a pointer. I don't know. So we're reaching the threshold of my understanding of something with this language. But that's talking about like the internals of the programming language and how many zeros and ones are being stored for each one. And I'm just learning all that stuff for this language. But anyhow, this is interesting, right? Like we're actually looking at the exact location in RAM where this variable is stored. It's at this precise location out of billions, right? We're at 34,899,899,034,656. Does that change every time we run it? So every time it's kind of going into a different cubbyhole in memory. And so the computer is referencing that, using that one location to store this little value and pull it out. So just think of RAM and memory as this huge post office box. Like you go to the post, what do they call that place? Post office. You go to the post office, and they have all those postal boxes with numbers on them. That's RAM, right? They've got all these little cubby holes with numbers on them, and you put things in, and you pull them out, and the computer, you know.
So actually, the ones you're saving something, when you save something on the RAM, it's actually a number.
It's getting put into a location where little switches are going on and off, right? And that location has an address.
Right.
That's the address, the memory address.
So,
Go ahead. What are you curious about?
Earlier I saw you coding. When you looked up one of the generators, it popped up one for the hexadecimals or capitalized letter and stuff.
Uh-huh.
Does it make a difference?
It just put out that X in caps, and it'd make all my letters capital instead of lowercase. So very observant of you. That's awesome. So yeah, formatting verbs. I could change the way something's formatted when I print it out. Decimal, binary, hexadecimal. So this is coding. And this is all computers are about. It doesn't get more complex than this. It does not. It becomes a little bit more abstract, and you learn new tools to work with all of this, but at its heart, this is it, right? It's just zeros and ones, which are switches that are on and off, and then we have different coding schemes. This arrangement of zeros and ones stands for one thing. This arrangement of zeros and ones stands for another. We could have 42 oranges. I have 42 oranges on my counter, and I could represent that as decimal when talking about that, which is what we always use. So we say the number 42, right? Or I could represent that as binary, which is another way to represent it. It's just kind of an abstraction over the zeros and ones. Or I could represent it as hexadecimal, you know? Or I could create a coding scheme that this arrangement of zeros and ones, you know, on and off, represents the letter A or B. And then it's just a matter of manipulating those zeros and ones and working with them.
Can you show 42 in hexadecimal?
Yeah. Yeah, 42 in hexadecimal is right here. It's 2A. We have 2 16s, and we have 10 ones. And 10 is the letter A, because when we hit 9, we don't want to go to 2 digits, because then we'd be writing 2 digits here. And we can't do that if we're putting a whole bunch of digits together to represent something. We got to have each space, just one thing represents something. So we got 2A, and that's A is 10. That throws people a little bit, right? When they're like, what? But instead of 10, I'm using A. That's it, right? Because I don't want to have to write 2 digits. I just want to write 1.
So A represent 10 and B represent 11 and so forth.
Mm-hmm. Yeah, but we stop at F because it's 16. And so here are my 16, base 16. Here are my 16 characters I could use in each space. 0 through F. 0 through 9 and A through F. That's hexadecimal. And there's a lot of people who are good intermediate programmers who couldn't explain this to you. There's a lot of people who are working professionally, earning $60,000 a year, doing web programming, and they couldn't explain to you how base 16 works.
So you've been teaching us a lot of the coding schemes. Are we going to apply it to our work on Blackboard, or are you just trying to teach us something new about computers, how coding schemes work?
So you won't apply this really to Blackboard, but you will use this in all of your life. And you have an understanding of computers, which the vast majority of people don't. And this entire concept of coding schemes, is super important. So just trying to, I think that's one of the most important points of the first couple of weeks of this class. So just trying to really drive that home and reinforce it so it really sticks. And understanding the difference between binary or decimal, binary, and hexadecimal, like that's a really huge thing to wrap your head around that. It's not super complex, but a lot of people aren't able to wrap their heads around it because they think it's complex, or they make it complex, or it's presented to them in a complex way. But you guys know computers run on electricity. Electricity can be on or off. If something's on or off, you could start encoding messages. If it's on, come trick-or-treating. If it's off, go away. My porch light, right? I've encoded messages into a circuit that's in an on-off state. Now let's just expand that. If I got 2 light switches, two lights on my porch, I could encode 4 messages. If I have 3, I could encode 8, depending upon the arrangement of on and off. I could create coding schemes to represent letters of the alphabet. Right? I can now also do different numbering systems, for representing numbers. All right, Q. That's just kind of a. How many people find that kind of fun?
I really like coding those, but when you do coding, I get really confused. All the little X's and little close and opens, and I think it's just because I'm not hands-on with it. But you make us do the hexadecimals and the binary and the decimals, and it's fun to learn it.
Okay, so I'm going to say something to you. You ready? Salamalat Tingal. Don't know that one? How about, sorry, I'm just having to rack my brain here. I'm just grabbing it off the top of the spot. Parlez-vous anglais? No? How about, hold on. How about, I just don't speak other languages. Anyhow, my point that I'm trying to drive home, right, is I don't know what that means, some foreign language, until you hang out with people who speak that language, and then they start teaching you things, and you're like, oh, I understand what that means now. And when you first go to a foreign country, you're like, what the heck did that guy say to me? And Salamalat Tingal, man, see you later. Oh, okay, yeah, see you later. Salamalat Tingal, Salamalat Jalan, I think, is the other way. I can't remember which one means which, but that's in Indonesian how you say, like, have a good time walking. I think that's what it translates to. Translate. So these are just coding schemes or something. Salamalat Jalan, road. So I must have mistyped that one. But, well, I got to go from English. But anyhow, you get the point, right? We don't understand. Yeah, it's kind of fun, like, see you later. Goodbye. We'll do goodbye. Same thing.
Sampai ketemu lagi.
Like, I don't know what that means, right? But hang out there long enough, right? And you will. Oh, I want Japanese. You will know what it means.
じゃあまたね。
Don't understand that one. I like the way Italian sounds.
Arrivederci.
Arrivederci. I understand that one. But so that's what programming is. It's just time on task, and you won't get it for, the first semester. You'll be like, what? Next semester you'll be like, oh, and then in 2 years you're like, I'm gonna go, like, I'm I'm going to like create a crawler, and I'm going to like suck out all their data, and I'm going to parse it and stick it in a database and analyze it, and then I'll know what to do. People will be like, what? You'll understand it. All right, so this week we're talking about operating systems. Anybody have any thoughts or questions about what we've already covered? So I'm just going to blow through operating systems here.
Do you feel like it's pointless when you do that?
What? Blow through operating systems?
Yeah, like do you think it's things we already know?
No, it's not pointless, but after like an hour of just goofing around and doing stuff which I think is kind of fun, it's like, all right, let's talk about operating systems. It's also important. But I like all your comments and questions, by the way.
Sorry.
Thank you. No, it's cool. I love the
I feel
interaction.
like I'm a bit intrusive, but I feel like we all work so well and we all work as groups on our computers and like you read through it, and then sometimes you ask us if we learn anything new, and majority of us kind of just think we already know it, so we don't really comment back. But that's why I was just wondering.
Okay, you guys already know. So you're saying you already know operating
Oh,
systems?
I'm not going to say that, but I'm just saying majority of the things you say. You always ask us back, and all of us kind of just think blankly. It's either we're not engaged, we're too embarrassed to answer, or we probably already do know it. And I was just wondering what you thought.
I don't know. I can't follow that.
When you write through the key terms, and you're just like, well, these are basic stuff. You're just reading back to us.
Yeah. I guess I really like your engagement. So if you don't know, let me know you don't know. And if you already know, say, I already know that. I don't know. But I think that there's a wide range of skills here. So lots of things, maybe a lot of people already know it, but I got to make sure I cover it so everybody knows it. So we're going to look at operating systems. We talked about categorizing stuff, and how academics like to categorize things, and they do that with computers. And we break computers down into what two parts? Computers, not software. We break computers down into what two main components? One's hard, one's soft. What do we call them? Software and hardware. So computers are made up of software and hardware. We've already looked at hardware, right? We looked at sort of the motherboard, the case, input and output devices. And now we're looking at software. Last week we looked at application software. Today we're going to look at system software, operating systems specifically. Right? So we could categorize software as either system or application. So computers are made up of hardware and software. Software is made up of application software and system software. And so here's system software. And it's made up of your operating system, your utilities, your drivers, your translators. So we talked about this last week a little bit. And we're going to look at your operating system today. Right? And so there's many different types of operating systems that are out there. Any device, any mechanical, any machine needs to have an operating system, right? So whether it's your little Timex watch, which you bought off Amazon for $28 because it vibrates as an alarm instead of beeping, and you didn't want to wake your wife up, so you bought that watch so you could wake yourself up but not your wife. Whether it's that one, or your MacBook Pro, right? They all have operating systems. Every little mechanical device needs to have some software which makes the system operate. Thus, it's called an operating system. Some of the main operating systems that are out there, like, for computers, personal computers, Mac OS X, Windows, Linux, Unix, iOS, Android for mobile, right? I looked up the metrics on operating systems, and here, the vast majority is Windows. Let me make sure I'm recording. 4346, 4350, cool. So here's desktop, laptop operating systems. And you can see Windows is 5317, that's 6070, and then 80. So Windows owns 80% of the market. OS X, which is Mac, Apple, owns 10% of the market. Oh, give another 5%, 85%, 87% to Windows. So Windows is really like 85% of the market. Mac is 10 or 11, and then we got other stuff. All right, that's kind of crazy. Windows is huge. But if you're going to go into programming at all, you need to know Mac. You need to know Unix, unless you want to be a Microsoft programmer. There's a couple of other little metrics up there which I was looking at. Here's this little graph. Kind of gives you a visual on it. Go away, floating hover thing. There we go, that's better. So Mac, dude, that's really small. Go away, little floating hover thing. That doesn't look quite right. Mac's more than that, so I don't know what the heck that one is. Look at all the pie charts. So those are some of the different ones that are out there. Anybody want to know about any of those? Have questions about any of them? Want to know like the story between Windows and how Windows came to be? And why they have so much market share? Do you care? Anybody want to know how Bill Gates became one of the richest, most powerful men in the history of humanity? He lied.
He lied.
Yeah, did I tell you this already?
Yeah.
I did, right? He told IBM he had something, he didn't, and then he went out and bought it. He knew a guy who he could buy it from.
They actually made another joke because of his story about how this average guy told I don't know, basically he promoted his son to be the CEO of Microsoft by telling another company that the son was engaged to Bill Gates' daughter and this and that. Like it was basically the same concept on Bill Gates' theory of how he got Windows. I forgot how the joke went, but it was basically how another man wrote his son to be CEO of it. I don't know. I can't explain it. If I remember the story, I'll explain it. It's a lot funnier.
I know, I've had those jokes too, dude. I've totally told jokes. I'm like, that wasn't funny, but it was when I heard it. I wish I could remember how it went. So anybody want to know about Linux? I think I already told you that. Linus Torvalds, right? Yeah. And then, I don't know, iOS and Android are pretty much just your phones. So command line GUI, when you saw me working at the terminal, that's a command line interface. Okay, so command line interface. And I just type in commands, and it shows me things. All right, so you got to remember all those commands and type stuff in. And then it shows you things, and you use more commands to access it and do stuff with it. That's how computers used to work. That's the command line interface. And then a graphical user interface is using graphics, and that's what we know. And that's not what I wanted. There we go. Right? So graphical user interface, I click icons and things like that. Now I don't know how to get back from there. There we go. So command line, graphical user interface. The operating system purpose is to keep the system running, right? Keep the system operating. It's the operating system. So the definition is reflective of the term. And so here's some of the stuff it does. It provides user interface. It boots the computer. Helps boot the computer. It manages the hardware, right? That's a really big piece. And it manages and monitors resources. Same way to say that. File management. So where are my different files stored? How do I move them around? And security. These are like the functions of an operating system. Not something you need to memorize. Just, oh yeah, that makes sense. So what's managing hardware is configuring devices, drivers, managing the CPU, scheduling tasks, memory management, what got stuck into what cubbyhole in memory, where is it? So that's all. You could think of it kind of like a cake. This is a software stack. So software stack. So we have hardware, and then on top of that you have an operating system, and on top of that you have application software. So every CPU, the hardware, every CPU has its own instruction set. And so different instruction sets for different CPUs. And the operating system needs to be written to tell that type of hardware how to work, right? So it could work with that piece of hardware. This CPU works this way. So it's kind of like, you need to have an operating system for, let's say you have an operating system for driving a car, except your friend says, here, take my car, and you go get in the car and it's a stick shift. You're like, ah, snap. I only know how to drive an automatic. The hardware is different. You need to have a different piece of software to run that hardware, right? And as soon as you get that software and you know how to drive a stick, you can drive a stick. But until then, you won't be able to. So every different piece of hardware, right, needs to have the software for it. And so different CPUs have different instruction sets. You can look that up, CPU instruction sets. instruction sets, Wikipedia, and just looking to see if they have any here. Yeah. So x86 versus x64. x86-64 is the 64-bit version of x86 instruction set. Supports vastly larger amounts of virtual memory and physical memory than is possible, and 32-bit predecessors, allowing programs to store larger amounts of data in memory. x64, 64, right? So those are like x86. There's also just x86. Let's see if we can find that. AMD 64 was created as an alternative to the radically different i64 architecture. Anyhow, so every hardware is made differently. And then there's certain standards. And so for a while, Macs were made on Motorola CPUs. And then Windows ran on Intel, like x86 CPUs. And so you had different operating systems. And then application software has to be written for the operating system. But the operating system's job is to help interface between the hardware and the application software. So it's like assigning different jobs to different pieces of software. So the operating system will know how to print. That means in my software, I don't know how to print. I just have to say, print this and give it to the operating system, right? And then the operating system knows how to print all the thousands of different printers that are out there. It knows how to print on whatever one you might happen to have. So have no fear when you're messing around with your computer. This is how you learn, and you could completely screw your computer up, the software, and you could just start over. A lot of times, like if I had a Dell XPS13 restore, right? You could just, Google your model on a computer that still is working, and find instructions on how to restore your computer to factory settings. And on your hard drive, very likely, it's got all of your original settings and all of your original software. And it'll just delete everything you've screwed up and put back everything the way it was the day you bought it. So that's a good thing to do with the computer if it's all messed up. It's got a bunch of viruses. You can just restore it. Make sure you take your work that you want to save off and back it up, because it won't be there after you restore. So you don't have to have any fear when messing around with software. Just know that if you mess it up too badly, you could just go to restore your system, or you could reinstall an operating system. So a lot of files have file extensions. So for instance, when I was at the terminal, you saw different file extensions, .txt, .json, and then here are hidden files, start with a dot. Right, so if I actually went in and looked at different files, changed documents, ls-la, see what I have in here. And so here are some file extensions right there. Right, so these different file extensions tell the computer what this file is and what it does and what piece of software I should use to open it. So if it's a .mp4, what does that file extension tell the computer? If it is MP3, what would it be? It'd be music, right? Like, oh, let me open this with something that plays music. So the computer looks at those file extensions to know, with this chunk of zeros and ones, what piece of software do I use to interpret it? A Word document? Is it a music file? Is it, a picture, JPEG? So here are some of the different file extensions. MP3, MP4 is video, MPEG movies, video. EXE is an executable. DOC is a Word document. So those are file extensions. And in Windows, you could right-click a file and choose Open With, and then say, hey, I want more options and always use this type of file. So you can reassociate in Windows and any operating system. Reassociate, that's how you do in Windows. Reassociate the file extension with what software you want to open it. So I could say, hey, instead of using this software to open my pictures, use that software. So I'm just saying, when you see this file extension, use this piece of software. We talked about minimum system requirements when buying software. It's just like basically you can look up what are the system requirements to run it. The removing USB drives. So if you just need, my friend calls these virus sticks, USB drives. It's a good way to get viruses spread around. But when you remove them, you should always right-click and say eject. Right, so down here I'm showing, hey, this is how I right-click and eject a USB drive.
Big Sur.
Yeah, that's Big Sur.
Aside from the cloud drives nowadays, what would have been the most suggested way, best way, instead of using USB sticks?
Oh, for files?
Yes.
Just stick it up into Google Drive, and Google Drive will.
That's why I said aside from that,
Oh,
before that became a thing.
yeah. I think it's just a flash drive, man. USB. Yeah, USB drive.
Would it be the thing as like an SD card?
SD card's pretty much like a flash drive. Same technology.
You can email it to yourself.
You can email it to yourself. That becomes cumbersome after a while.
I do love hearing from me.
Huh?
I said I do love hearing from me. I was just kidding.
Utilities, right? We talked about these. What are they like? What's the analogy I gave you? They help what? Utilities in your house do what? Help keep your house running. Utilities in your computer help keep your computer running. What are some examples of utilities in your computer? What's an example of some utility helps? What's something that helps keep your computer running? Let's take away the word utility.
Downloading.
What is it?
Download.
Downloading? Sure. So you got software that automatically downloads for you. That could be considered a utility. Helps keep your computer running.
Tower.
Huh?
A tower.
The tower? Well, not so much. We're talking about software here.
Firewall?
Firewall software? Maybe.
Windows.
So what I'm thinking of is like, antivirus software. It's kind of the category I'm thinking of. Or backup software, So that's a utility. Backups. When you install and uninstall software, you could sometimes just right under the software, you could find uninstall when you're looking there. Or you could go to add, remove programs. I know I'm showing you like the Windows 7 way. Go add, remove programs, and then choose change, remove to get rid of software.
You could just go to the search now, right?
Yeah, you can just go into search.
Right, uninstall.
Yep. So if you're on Windows, I have a way of decrapifying your computer, which I can't show you because I'm on Mac. It's unfortunate. I used to show people how to decrapify their computer. But I will show you how to do it. So MSCONFIG. So at your little start thing, in the search area, you just type in MSCONFIG and it'll take you to something that looks like this. And so this guy here, it shows you what gets started at startup. And so you could go into there and you could say, I don't want this stuff starting in startup. Like I don't want, I don't know, Adobe updates to start at startup. I don't need that. I'll update Adobe, or when I start Adobe, it checks automatically. So I don't need it checking if I haven't started it. So if you have a computer that's kind of bogging out, just go through here and disable all and let it figure out what it needs and it'll turn it on. So you could, and it'll ask you, are you sure you want to do this? And you need to restart. And last time you were running, you turned a whole bunch of stuff off. Is this okay? It'll ask you all that. So MSCONFIG helps you decrapify your computer. You could also go into Windows and search for performance, and it will it'll adjust for best performance. So just search for performance, and it'll take you into like advanced here, and you click, I can't remember what, but eventually you get to this, and you just choose adjust for best performance, and that helps your computer run faster. And just trying to remember what else. I think that's enough. See if I have anything in my notes. No. So I already told you about the Microsoft story. Here's one of the original Apple computers.
Nice. Wow. Looks like a typewriter.
And here's the original logo. Totally 70s.
That's crazy.
There's a funny YouTube video, Letterman and Gates retirement. You could Google that on your own or YouTube that on your own. You know, it's a little bit funny. That's the guys who started Microsoft. There's Bill Gates. He's like 20. All these people are richer than the devil.
Wow.
Or God, whichever way you want to say it. Not quite, but it's the original group. If you want a little history of Microsoft, Apple, you can check out Pirates of Silicon Valley. It's kind of a cool movie. That's it. Operating systems. I looked at the terms, and there's not much more in here to know. Unless you want me to go through them and say, you already know this. You already know this. You should know that. Anybody have any questions? How many people today was worth your time? How many people is a waste of your time? Just curious. Like, am I giving you what you asked for, right? You ordered a pizza. Did you get, you know, focaccia? And you're like, what's up, man? I wanted a pizza. Make sure you're getting what you're ordering. All right, well, that's all I got, unless you got anything. Should I stop?